Okay, this is topic 9.6, direction of vectors. Today we're going to look at direction of vectors and then combine magnitude and vectors to solve magnitude and direction of vectors to solve problems. So the direction of a vector is the angle that it makes with a horizontal line. So the angle is measured counterclockwise from the positive x-axis. This is one way that you can measure the direction of a vector. So this first picture shows you vector AB. And we're talking about this angle that that vector makes with the horizontal line. And so if we imagine that we have a coordinate plane with an x and a y axis, then, whoops, let's put the y axis in a different place. With our x and our y axis, then the amount of degrees from the positive x-axis to the vector would be the vector's direction from the positive x-axis. So that would be 60 degrees. And you can also measure the direction of a vector as a bearing relative to the compass directions north, south, east, and west. And so the problems that we're going to be doing will mainly be giving us directions from the north. And so this vector AB, when you look at the coordinate plane and with the compass directions north, south, east, and west, then you can see that we're measuring this angle from the north. So this vector is 30 degrees east of north. And that's how you write it. You don't write northeast. You say that the vector is 30 degrees east of north. And so we write it like this with the N in the front and the E behind. And so we're going to practice just writing down what these directions are based on their compass bearings or their direction from the positive x-axis. So let's write each direction from the positive x-axis and each bearing from the north. So here is my vector. I'm going to put my vector in green. And I want to first write its direction from the positive x-axis. So here is the positive side of the x-axis. So from here, I want to go counterclockwise, and I'm going to come around counterclockwise until I get to the vector. And I want to know how many degrees is that? Well, we all know that this is 90 and this is 90. So all the way to the negative side of the x-axis is 180 degrees, plus I've got 70 more degrees to get to the vector. So 180 plus 70 means that my vector is 250 degrees from the positive x-axis. We always go in the counterclockwise direction. Now, what is this vector's direction from the north? So let's look at it again in terms of direction from the north. So here's the north, and so I want to do the shortest distance from the north. So that would be going to the west to get to the vector. If I go to the east, it's further. So I want the compass bearing the shortest distance from the north. So again, we know that this is 90 plus 70 more to get to the vector. So from the north, I'm going to add those together, and so that would be 160 degrees west of north because we're going closer to the west. Or we're going on the west side of north. So we're going to put it in first, and then we're going to write 160 degrees west of north. All right, let's try another one. So here's my vector. And let's first get its direction from the positive x-axis. So going counterclockwise from the positive x-axis, I am going 70 degrees. So the direction from the positive x-axis is 70 degrees. Now let's do our direction from the north. So the shortest distance from the north to the vector would be going towards the east. And how many degrees is that? Well, we know that this whole angle, these two angles together, is 90. So 90 minus 70 would be 20 for this angle right here. So we would say that that vector is 20 degrees east of north. So we put our north first. So from the north, it's 20 degrees east of that. So we can give direction from the positive x-axis and from the north, and most of the problems that we work in, we're going to be looking at where the vector is with its bearing from the north. Okay, so let's look at a couple of examples. In example 1, we want to find the magnitude and the direction from the positive x-axis and from the north for vector u. So vector u is in component form is -4, 3. So let's remember from the last lesson that if it's given to you in component form, then you know the initial point is going to be at 0, 0. So I'm going to start at 0, 0, and my terminal point will be at -4, 3, because my horizontal change is -4, and my vertical change is 3. So I'm going to draw in my vector, and let's make a triangle out of it like we did yesterday, or on the last lesson. Here's my right triangle, and I know that this side of the triangle is 4 and this side is 3, so we know that the magnitude of vector u, so remember we're going to put our symbol, vector u, that means the magnitude. We know the magnitude or the length of the vector would be 5. All right, number 2. Now we want to find the direction of the vector from the positive x-axis and from the north. So let's start with from the positive x-axis. So from the positive x-axis going counterclockwise to the vector, how many degrees is that? Well, we know this is 90. We've got to figure out what this angle right here is. And so let's find the angle that's inside of the triangle, because we know how to do that. To find that missing angle inside the triangle, we need to use SOHCAHTOA, right? And when we want to find angles, we want to use the inverse. So in relationship to that angle, 3 is our opposite side, and 4 is our adjacent side, so we're going to use tangent. But since we're looking for the angle, we're going to use tan inverse of opposite over adjacent. So you're going to go in your calculator and make sure that you're in degree mode. And we're going to do second tan of 3 over 4. And rounded to the nearest degree would be 37 degrees. So that angle inside the triangle is 37 degrees. So to find the angle measure from the positive x-axis to the vector, we just need to do, let's do direction. So to get that, we can just do 180 minus the 37. Because we know that from the positive x-axis to the negative x-axis is 180, because that's a straight angle, minus that 37 will leave me with 143 degrees. You also could have done 90 minus 37, which would have been 53. And so we know that this angle right here is 53. And so you could do 90 plus 53 also. All right, so that's from the positive x-axis. Now let's do from the north. So what is the shortest distance from the north to get to that vector? So here's the north. So we would go towards the west to get to the vector from the north. And so we decided that this angle was 53 degrees. And so our bearing from the north will be 53 degrees west of north. So I'm going to put the N first. So from the north, it's 53 degrees west of north. So you're going to make a triangle out of your vector. And you can make it whichever direction you want to the x-axis or the y-axis. You're going to find the missing angle to help you get your direction. So the problems that we're about to look at are going to be dealing with the speed and direction of an object. So when a vector is used to represent speed in a given direction, the magnitude of the vector, which we've been calculating as the length, equals the speed. So for example, if a vector represents the course a kayaker paddles, then the magnitude of the vector is the kayaker's speed. So you want to remember that in most of these problems, that the magnitude equals the speed. All right, so let's see what type of problem that we would use this in. So example 2 says the force exerted by a tugboat is given by the vector 7, 3. Draw the vector on the coordinate plane and find the speed of the tugboat to the nearest tenth and the direction of the tugboat from the north to the nearest degree. So our vector is given to us in component form. So let's draw our vector with the initial point at 0, 0. And our horizontal change is 7 and our vertical change 3, so our terminal point is at 7, 3. So I'm going to make a triangle out of that. Here's my right triangle, and I know this side of it is 7 and this side is 3. So the first thing I want to do is find the speed of the tugboat to the nearest tenth. So when I want to do that, that means I'm looking for the magnitude. So the magnitude of this vector, we're going to do Pythagorean theorem because it's not a triple. So we're going to do 7 squared plus 3 squared, and then we need to take the square root of that. So to the nearest tenth, punch that in your calculator. So 49 plus 9, 58. Take the square root, and you should get 7.6. So in this case, it doesn't tell us what type of speed, but the speed of that tugboat would be 7.6. Maybe it's miles per hour, something like that. Okay, so number 2, we also want to find the direction of the tugboat from the north. So remember, when we want to find direction, we're going to need angle measures. So we're going to find that missing angle that's inside the triangle. And remember, when we want to find missing angle measures, we're going to do inverse. Across from the angle is the opposite, and next to it is the adjacent. So we're going to pretty much be using tangent every time to find that missing angle. So we want to do tan inverse of 3 over 7. So go on your calculator and type in tan inverse of 3 over 7, round to the nearest degree, and you should get 23 degrees. So now what we can do is we want to find the direction from the north. So the shortest distance from the north to the vector is this way, so we want to also know this angle measure. And so just keep in mind that these two angles together make 90. So to get that angle, we're going to do 90 minus 23. And that gives us 67. So the direction from the north, that's to the east side, and so from the north, it's 67 degrees east of north. Okay, so let's look at example 3. This says, suppose a kayaker paddles at 4 miles per hour at a bearing of 40 degrees east of north. Write the vector for the kayaker in component form and round to the nearest tenth. So we are going to, we don't have a grid this time, and so we just want to look at if the kayaker is paddling at a speed of 4 miles per hour. Remember that speed is the length of the vector. Speed is the magnitude, so that's the length of the vector. And we know it's at a bearing of 40 degrees east of north. So I know, here's my north and here's my east. So I know that my vector is on this side. And if it's 40 degrees east of north, then I know that this is 40 degrees right here, from the north to the vector. So the length of the vector is 4, because it's going 4 miles per hour. The speed is the magnitude, which is the length of the vector. So I'm just going to make a triangle out of this vector. And this time, I don't know what this x is, and I don't know what this y is. I don't know the horizontal change and the vertical change. I need to find that so that I can write the vector in component form. So how am I going to get the length of x and y? Well, if this angle is 40 degrees, then I know this angle inside the triangle is 50. And so I'm going to use SOHCAHTOA and that angle measure, and I'm going to find each part, each horizontal change and vertical change, so I can write my vector in component form. So let's find x first. So to find x, then I know that this is the adjacent leg to the 50, and I know the measure of the hypotenuse. So adjacent and hypotenuse would be cosine. So I'm going to do the cosine of 50 degrees equals x over 4. And then I need to solve that. So I'm going to put cosine 50 over 1, and I'm going to cross multiply, and I know x is going to be 4 times the cosine of 50. I don't need to inverse here because I'm not looking for the angles. I already know them. I'm just going to punch that into my calculator and make sure I'm in degree mode. So everybody type that in. Then x will be rounded to the nearest tenth, would be 2.6. All right, so I know that my x, or my horizontal change, is 2.6, and now I just need to get my y value. So in relationship to the 50-degree angle, y is the opposite, and I know the hypotenuse. So this time I'm going to use sine. So I'm going to do the sine of 50 equals y over 4. Put it over 1, cross multiply, I get y equals 4 times the sine of 50. So to the nearest tenth, punch that in your calculator. Then y should equal 3.1. So this vector in component form then is the x value is 2.6, so that's my horizontal change, and my y value is 3.1, that is my vertical change. And so my vector would be 2.6, 3.1. All right, so let's summarize what we've talked about. So component form lists the horizontal and vertical change from the initial point to the terminal point. So look at this example. If I have my initial point at 2,5 and my terminal point at 8,4, then if I write that vector in component form, this is vector PQ. I'm going to do 8 minus 2 and 4 minus 5. I always do terminal minus initial. And so my vector in component form then will be 6, negative 1. All right, so let's take that vector in component form, and if we want to find the length of it, or the magnitude, we can use the distance formula or make a triangle out of it. And so if we make a triangle out of it, and we know our component form is 6, negative 1, then to find the magnitude of that, I'm just going to do 6 squared plus negative 1 squared and take the square root of it. So we already did the x2 minus x1 and the y2 minus y1. And so we just want to square which gave us this. And so we just take those numbers in the component form and square them, and that will give us our magnitude. So this would be the square root of 37, and rounded to the nearest tenth, the magnitude of vector PQ would be 6.1. So here's our vector in component form. We find the magnitude, which is the length of the vector, and magnitude equals speed. And then for direction, we make a right triangle, and we use tan inverse to find that missing angle that is inside the triangle. So for example, on this one, here's an example. You would do tan inverse of 6 over 5, which gives you 50 degrees for that angle. All right, so let's take the one that we were working with, and let's find the direction from the positive x-axis. So I'm just going to make myself a little sketch here, and I know that 6, negative 1, that vector would be over here. 6, negative 1. So I know that those would be the two sides of my triangle. And so I want to find the direction from the positive x-axis. I have to go counterclockwise all the way around. So let's just calculate this missing angle inside of the triangle. So I'm going to do tan inverse of 1 over 6, opposite and adjacent. Punch that in your calculator. Tan inverse of 1 over 6 gives us 9 degrees. So from the positive x-axis, then I want to take all the way around as 360 degrees. minus the 9 degrees gives me the direction from the positive x-axis. So that would be 351 degrees. All right, and then direction from the north. What's the shortest distance to the vector from the north? It's going towards the east side. So I know this is 90, and I already found this angle to be 9. So I just need to do 90 plus 9, which would be 99 degrees east of north. So my direction from the north, 99 degrees east of north. All right, so those are all of the things about vectors that we're going to use to solve problems. You can find either speed or direction using magnitude and angle measures.